Section E is running fixes, so this will be a means of finding our position using only one landmark. They've given us the data in a table format as well. A couple strange things about how it's presented, and we'll go ahead and deal with that in our workings before we start the plot. But we need to find our landmark for question 1. It's green point light. So this time, I'm all the way down at the bottom of the chart. Lower left-hand side, this first lighthouse here is going to be green point light. So this is the object we're going to be taking bearings on in order to find our position. The data, in the way it's presented, they've given us 2 bearings. So at time 1, we're somewhere on this bearing, and then time 2, we're somewhere on this bearing. They've also given us a course to steer, a course steered in between the 2 bearings. And note that this is degrees compass using the ship's steering compass, whereas these are degrees magnetic using a handheld compass for convenience when shooting the bearings. We're going to have to convert these all to true, carefully keeping track of those units before we get started. And then they've also given us a means of finding a distance traveled. That's a log reading here. Log, we're talking about the kind of traditional speed through water measuring tool on the boat, which can give you either a distance or a speed. And so you can kind of think about this for this problem like a car's odometer or your mileage gauge, where you started with 0 miles, you ended with 5 miles, so guess what? You've traveled 5 miles during the course of that problem. So let's go ahead and deal with some of our given data first. So this will be number 1 from section E. And so we're working with the green point light again, and our first line of position has a magnetic bearing of 321 degrees. Our second line of position has a magnetic bearing of 261 degrees. And so we'll want to set up a table, TVM. Anytime we're going that way, we would add whiskey, but anytime we're working back, we would subtract west. And just like every other problem, we're going to be working with 25 degrees west variation, 25 degrees west variation. Get out the calculator if you need it. 321 minus 25, that should give us 296 degrees true. We can put that line on the chart. Do that again, 261 minus 25, we got 236 degrees true. We can put that line on the chart. And while we're here, we'll go ahead and get all of the relevant data for this problem. So they also give us the ship's course steered, which I'm just going to abbreviate as the ship's heading. Now they've given us in degrees compass, so let's set up a full TVMDC. I like to do this separate just to ensure that I haven't mistakenly done the conversions wrong between these 2 sections. Now, again, our course steered is 016, so we're going to need a deviation. Coming to that deviation card, looking for the nearest thing to 016, I've got 10 and 20. I'm pretty much halfway in between, but if I round it up to 20, it would be 7 east. That's set at 7 east either way, so that's pretty convenient. Since I'm working from compass back towards true, I'm subtracting west, adding east. So 16 plus 7, that should come out to 23 degrees magnetic. Variation of 25 degrees west, that would give me -2, but of course that's not on my ship's compass, so that must be 2 degrees past 0, or 358 degrees true. So these are the bearings that I can put on the chart. And then again, the ship's log reading is pretty easy in this case, but if you need to know your distance traveled, let's go ahead and take the log reading from time 2 minus the log reading from time 1 to get that distance that we've traveled along the ship's heading. So in this case, real easy, 5 minus 0, that's going to be equal to, good work. That's going to be equal to 5 nautical miles. Let's get rid of that. That's the value we need. And we can go ahead and transfer that work over to the chart now. All right, so we need to plot our first and second line of position on the chart. So we've got line of position 1 is 296. So 296 on the ship's compass is right about here. On the compass rose. So we'll go ahead and accurately line those rules up. That's going to come down to green point light. Careful not to slip along the way. So here is going to be line of position 1, 296. Arrow on the end. Let's call that 296 degrees. And let's also call that LOP1. Second line of position is 236, so that should be right here on the compass rose. Bring that back to green point light. Okay. Call that one 236 degrees, LOP2. And it's good to note which one was first, which one was second, because sometimes your vessel is heading this way, making this line of position 1, this line of position 2. In a subsequent problem, you might instead be heading in the opposite direction, which would change the order. In between those two lines of position, we were traveling in direction 358. So let's go ahead and find that on that outer compass rose. Nice and accurate. Now remember, this line can go anywhere from line of position 1 towards line of position 2, because our final step is going to show us where it should be. So I'm just going to choose to put it here, but if yours doesn't quite match mine, that's okay, as long as our resulting position looks pretty similar. This is our ship's heading, so we're going to call that the water track. And we know that our ship has traveled 5 miles in the course of this problem. So we're going to go ahead and measure out 5 nautical miles on the latitude scale in the vicinity of our work. Starting here, working towards line of position 2. We're just going to go ahead, give that a little hash mark. And then the key point to our running fix is there's only one place that all 3 of these lines at that distance should fit together. And to find out where that is, we're going to take LOP1. We're going to move it forward up to the point it intersects that distance traveled. We'll go ahead and draw on a nice line here. 2 arrows on both ends because this is a transferred line of position. And we already knew that position, that was our distance run. So that's showing us this position right here, which is the fix, the position where LOP2 is intersected by that transferred line of position. For this problem set, they've just asked you to plot the position, so that's your final answer right there. You might also want to be able to find the latitude and longitude, in which case you could line up your rules with an existing line of latitude or longitude, accurately then find out what it is from the scale.